All right, so we're continuing our journey to a better understanding of the base 12 version of pi by looking at this 360-degree diagram that we're creating using base 12 geometry and the geometry of the base 12 dodecagon. So in this video, we're looking at the 7th ring of this diagram. So we're going to do the same procedure that we've been using for the previous 6 rings. We're going to start by multiplying 3.2 root 2 by 7. 3.2 root 2 is the section of between each ring, the section of length between each ring in units of square root of 2. So 3.2 root 2 times 7 is 1a.2 root 2. So we're traveling along the 39-degree line, 45-degree line in base 10. We get to that lattice point, we draw our first radius, then we add 0.5 root 2 at a 90-degree angle, and then we draw our second radius circle. So we follow those two circles down to the x-axis, and we can find the square root versions of those radiuses, and we find their x-coordinates on the x-axis, and we can figure out the distance between them. Again, very small gap. And we can look again at the places where these radiuses of the circles cross the degree lines that we've already established. And again, we're using the red lines and the blue lines as our main anchors, and we can see here we're going to twin all of the red lines. That's the x-axis and the 13, 26 and 39 degree sections, 15, 30, 45, and then the 7.5 degree sections, the blue lines, we can draw circles on there. So once we do that, we can see there's still some gaps in between the pattern, and what we're going to do is find the midpoints. And those are our new degree lines, and then we're going to twin those lines, and that's how we fill all the gaps, and we have a consistent ring of small circles, and we put the larger circles around those, or draw the larger circles around those, find the midpoints again between them, and that generates all the degree lines for our next series of circles. So this is the 7th ring. So the 14th ring, we'll be using all of the degree lines that we've generated in this ring on that ring. So that's how the pattern works. So we can figure out the interior angles of all those small circles. We use our formula n minus 2 times 130 divided by n. So we plug in the right number and we get the degrees of 129.835186. So that's our first repeating decimal. It's a repeating decimal. Then we can also figure out the sections of degrees that we're creating on the circumference, again by using our formula 26 divided by 24, I think it is. So again, we get 1.083586. So again, a repeating decimal. This is our first ring of repeating decimals. So basically that's all the information from this particular ring. What we're going to do in the next video is look at some other details of the overall diagram and then keep going until we get to the final ring for 300.